Pre-calculus notes 8.2, dealing with logarithms and properties and trying to put them to use. This is the last video, 4 of 4. Solve each of the following equations. Now, it's likely that that's just going to be the directions for x. But it's given you some pointers here as part of the directions because we're new to this. By rewriting each side of the equation as a single logarithm of the same base, and then set the arguments equal to each other. So here's what it's saying. It's saying we want to use this property, the property of equality. Property of equality says that if you have a single logarithm equal to a single logarithm, and they have the same base, you can just take the arguments and set them equal to each other. So that's what we're trying to accomplish in this. We currently don't have that. On the left, we have multiple logarithms. I'd like to use the product property to condense this into one logarithm. I currently can't because of this coefficient. So I'm going to move this 2 as an exponent here and make this common log of x, plus common log of 2 squared equals common log of x plus 9. Now I can use the product property and multiply these two arguments using this common log. Hope that you all understand that 2 squared is 4. So this is going to be common log of 4x equals common log of x plus 9. Now using the property of equality, which once again is this fellow right over here, we can set the arguments equal to each other. So 4x is equal to x plus 9. If you subtract x from both sides, you get 3x is 9, therefore x is 3. It says check your solution. So to check your solution, let's just do it mentally. If we put 3 in here, we put 3 in here. On the right, it's going to be common log of 12. On the left, we put a 3 in here. We're going to have common log of 3. Put the 2 here, it would be 4, so it would be common log of 3 plus common log of 4. When you add these, you multiply the arguments. So it would be common log of 4 times 3, which is 12, equals common log of 12. So it works. Number 2. We can write this as one logarithm. We don't have any coefficients here. Since we're subtracting the logs, we're going to take the positive argument. Let me rephrase that. We're going to take the positive logarithms argument and write that in the numerator. Write the negative logarithms argument in the denominator. And the right side was already one logarithm. Using the property of equality for logarithms, since we have a log equal to a log and they have the same base, we can set the arguments equal to each other. This is a simple algebra equation. If we multiply both sides by deuce, we're going to get x minus 4 equals 2x plus 2. And then if we subtract 2 from both sides and subtract x from both sides, we get x is negative 6. Now, something I should have mentioned earlier, number 1, and I didn't. I apologize. Looking at number 1, looking at all of these, if your variable is your argument, which it is here, we had a rule here at the beginning as part of the definition for logarithms that the argument has to be positive. So what I'm saying by that is, at the beginning, we probably want to do something like this. Say, hey, by the way, x plus 9 must be bigger than 0. Therefore, x must be bigger than negative 9. If this answer is not bigger than 9, then the answer doesn't work. Similarly, over here, this has to be bigger than 0. If it's bigger than 0 and bigger than negative 9, it just means it has to be bigger than 0, which this is. Looking at number 2, here we're saying x plus 1 has to be bigger than 0, x has to be bigger than negative 1. Here we're saying x minus 4 is bigger than 0. X has to be bigger than 4. This is not bigger than either of these. Actually, it's bigger than, no, it's not. It's smaller than both of them. This problem has no solution. Once again, it has no solution because if you put a -6 into this, you're going to get common log of 3 to the -10. The argument has to be positive. Put -6 in here, you're going to get common log of 3 is -5. Doesn't work. This has no solution. If you don't pay better attention, which I didn't to the first one, I was a little bit alarmed when I got this negative, and I thought, oh yeah, I forgot to do this. Always make sure your arguments are positive. So number 3, let me set a better example for this. Off to the side, so I don't run into my work, I'm going to say x plus 2 has to be bigger than 0. So x has to be bigger than -2. It's coming from this one. And from this one, I would say x has to be bigger than 0. So we get an answer for 3, and it doesn't make both of those true. Well, then we're going to be in a little bit of trouble. And I, for one, do not want to be in trouble. All right, on the left, we can add these two together by saying, using the product property, log base 2 of x squared plus 2x. I have multiplied the arguments. On the right, I'm going to use the power property and write this as log base 2 of 8. The reason that tell you what, I could actually do that simpler. There's nothing wrong with this, but what is log base 2 of 8? It's 3. Here's another reason why I know it's 3. This is 3 times log base 2 of 2. But what's log base 2 of 2? This is asking 2 to what exponent is equivalent to 2? That answer is 1. So this is just 3 times 1. Now when we get to this point, if you've written it this way, this would not be possible for us to use the property of equality for logarithms because there's no logarithm on the right. So what can we do? We can change this. This is right now in log form. We can change this to exponential form. Nothing else that I would know what to do here. If I change it to exponential form, it would be 2 to the exponent equals the argument. Now we have no logarithms. We have no variables in the exponents. This is doable. 2 cubed is 8. I'm going to get all the terms on the same side so I can factor. Two things that multiply to get -8 and add to get +2. So this would be x plus 4 and x minus 2. If I set each of these factors equal to 0 and solve, or if I use the what theorem was that? The factor theorem. If I use the factor theorem, I can go directly and say, well, x is -4 and x is 2. But you got to be careful because up here we're saying x has to be bigger than -2 and it has to be bigger than 0. This one here is not bigger than 0. So the answer is x equals 2. Long story short, number 3 was different because the right side collapsed down to just 3. So we didn't have a log equal to a log. So we changed to exponential form and was able to solve this by factoring. Let's see, we got 2 more of these little fellows. On the left, we have the same base, natural logs, and so do we do on the right as well. So on the left, I'm going to write this as natural log of x plus 3 over 2. It's the quotient property. We're subtracting these logs, write it as one log. The positive logarithm, its argument goes on top. The negative logarithm, its argument goes on the bottom. On the right, we're going to have natural log of 6x minus 3. We are adding two logarithms, the same base, e. So we multiply the arguments. 3 times 2x is 6x. 3 times a minus 1 is a minus 3. We can now set the arguments equal to each other. That's the property of equality, which says if you have a log with the same base equal to a log with the same base, you can set the arguments equal to each other. Now it's an algebra 1 problem. If I multiply both sides by 2, I get x plus 3 is 12x minus 6. If I subtract x from both sides and add 6 to both sides, I'm going to get 9 equals 11x. And if I divide both sides by 11, I get x is 9/11. Now I forgot at the beginning, shame on me, to make sure my arguments are bigger than 0. So the answer has to be bigger than -3, which that is. For this other one, it has to be bigger than 1/2, which it also is. So this answer works. Got to always check this every time, even if I forget. Last one, the right side is the left side is already one logarithm, and each of these logarithms have the same base. The right side, I need to get this to be an exponent. So I could write this as natural log of x over 4, just to emphasize how that happened. I could take the coefficient and write it as an exponent for 2. 2 squared is 4. The logarithm that we are subtracting, its argument goes on the bottom. The logarithm that is positive, its argument goes on the top. Property of equality, I have two logarithms with the same base equal to each other, therefore I can set the arguments equal to each other. Once again, this is an algebra 1 problem at this point. There's no variables in the exponent, there's no logarithms. We're going to multiply every term by 4 and get 8x minus 12 is x. I'm going to subtract 8x from both sides and divide both sides by 7. And before I make any conclusions, I got to make sure that my arguments are bigger than 0. We got x is bigger than 3 over 2. X is bigger than 0 for these. This is bigger than 3 over 2, and it's bigger than 0, so this answer works. All right, that concludes 8.2 notes. Please do the accompanying homework.